All right, so you guys have in the middle this matrix multiplication chart, which you can read through, kind of explains what the book uses matrix multiplication for. I think I'm going to jump to our next page here. All right, so here we go. Got my correct page up here. Then the thing we want to focus on from this little box, the matrix multiplication, is where they give you the dimensions. So they say your A matrix is an M by R matrix. So we'll pretend this has dimensions. So rows is the M, and maybe 3, and the R's could be like a 3 by 2. And we're multiplying that by an R by N dimension matrix. So the big thing that we need to pay attention to is we need this middle number, the columns in the first and the rows in the second, to match up in order to multiply our matrices. If they do match, then the dimensions of our answer are going to be that first row and that last column. So this answer matrix for this case would be an M by N matrix. So we'll see that in the next couple examples, but just keep that in mind. You can only multiply matrices when these two dimensions match. So trying out our first example here, we've got a 1 by 3 matrix, right? 1 row and 3 columns. And we have a 3 by 1 matrix. So that's 3 rows and 1 column. We're all set. We can multiply these since those inside values match. Our answer is going to be a 1 by 1 matrix. Okay, so when we're multiplying matrices, if you check up top, all the answers, right? So I underline that A11, B11, C11. That stands for the entry for the 1 is the row, and that second one is the column. So if we only have one answer down here, it's going to be entry A11, which means I'm using the first row. Get a little marker here. From the first matrix and the first column from the second matrix. So just writing this out, I'm going to take the first row. So I'm going to take 2, multiply it by the first number in the second column times 4. Then I move down to the next number. So I'm taking this 5 plus 5 times my next value, -6. And then the last values, 1 and 5 from that second matrix. So I took every number in the first row and multiplied them individually by each number in the second column. So we're only using every number once if we had this one entry. So for this one, I would just simplify all those. I'd have 8 minus 30 plus 5. So our answer here would be just a 1 by 1 matrix of -17. Okay, so let's actually go on to a matrix now. It's a little bit larger. We have C and D here, and C is a 2 by 2. D is a 2 by 3. So we're going to multiply these together, and we can because the inner dimensions match. So this 2 and this 2. And our matrix result should be dimensions 2 by 3. All right, so I'm going to really take my time on this one, but if you guys think you get the hang of it, feel free to go ahead. My answer matrix will have 2 rows, so I'm going to draw out those 2 rows, and 3 columns. So I'm just going to put here all of like our space holders for this matrix. And then I'm going to fill out 1 by 1. So I'm just going to erase this 2 by 2 so I can draw and kind of change as I go along. So our first position, that's the first entry here in row 1, column 1, we called it A11 before, is just exactly that. I'm going to use row 1 from the first matrix, and I actually circled the column instead of the row. We're going to use row 1 from the first matrix, column 1 from the second matrix. And I multiplied these together. So I have that 3 from the first matrix times -2 from the second. I'm adding that with -1 for my first position times the 3 from the second. So I just took those values from the first row and then the first column. All right, now moving on to the second position. This is going to be we're still in row 1, but we're in column 2. So instead of taking row 1, column 1, we take row 1. Now I'm going to use a different color. We want to use row 1 and column 2. So I'm going to have still 3 from the first matrix, but I'm taking the 0 from column 2. I still have negative 1 from the first matrix, and I'm taking the 5 from column 2 of my second. All right, so I'm going to keep going through in this pattern. I'm going to talk through it a little bit less. Maybe I'll just show the last one. So for the last row, or the last position in this row, this would be position A1, 3, right? Row 1, column 3. So I'm using row 1 from my first matrix, column 3 from the second. And I'll write it out here using the black pen. So this would be 3 from the first times 6 from the second, the negative 1 from the first, and the 1 from the second. All right, so I'm going to continue with this pattern. The bottom positions still think the same thing. So think about what position in your matrix this is. For this one down here, it's row 2, column 1. This would be row 2, column 2. Row 2, column 3. So we're taking the appropriate rows and columns. So I'm just going to jump, I'll do like the last one over here as our example. Over here, this is position row 2, column 3. So I need to take row 2, multiply it by column 3. So that's 4 times 6 plus the 0 times, it doesn't really matter, right? 1. All right, so try to fill in those two other positions. I'm going to write it out. So I'm going to pause my recording, write in the answers, and then check your final matrix for C times D when you're done. All right, guys, so I just wrote in the answers there. So you can check that out, right? And if I went through to my final matrix, I'll just quickly put that in here. This should be what our full answer looks like together. So after you add up all your terms, that's what we should get, which is a 2 by 3, just like we said. All right, so if we try to multiply D times C, and I'm just going to erase this matrix here so I have some room to write. Let me get a bigger eraser. Okay, so if we try to multiply matrix D times C, notice D, right, like we said before, is a 2 by 3 matrix. And C is a 2 by 2 matrix. So if we tried to multiply these, since those middle dimensions are not the same, it wouldn't work. So DC is a matrix that does not exist. We can't find that. All right, so that's our matrix multiplication in a nutshell. I'm going to do one more example. If you're feeling good about it, definitely go on in your packet. If you want to just try an extra one, you can hang here and try that out. All right, so here's the last example I'm going to work through. I have a 1 by 2 matrix over here and a 2 by 4 matrix over here. We can definitely multiply these because our middle dimensions are the same. My result is going to be a 1 by 4 matrix. So I'm going to just start off with my positions, and I'm going to kind of take this a little less step by step than last time. So to start off here, I'm multiplying my first row. So that's, and I'll just underline, our 2, negative 3, right, the only row we have there, times our first column, 2, negative 6. So my values here, I'm going to have a 4 and then negative 3 times 6. So minus 18, that'll be my first entry. All right, then we're moving to the second entry. So we take the first row, that'd be our 2 times 0, times, or add it to the negative 3 times the 1. So minus 3, that'd be my second entry. My third entry, 2 times 5 gives us 10. Negative 3 times 0, that's a 0. And my last entry for this matrix would be the 2 times the -1, -2, and the -3 times the -2, that would be plus a 6. So that's all of kind of the legwork for this. Then we're just adding together. So our final matrix would be our 14, -3, 10, 4. All right, you can also check these with your calculator. You would just put your first matrix into, that's kind of messy, put your first matrix in for A, put your second matrix in for B, go back out to the regular screen and just multiply them together. So you guys can definitely try that out to check. All right, I'm going to end it here for our first video. This is just matrix multiplication. If you're feeling good about that stuff, you can go on to the next one that will talk about inverses of matrices.